Hi everyone, today we're going to be finding the linear regression of a data set using your scientific calculator. So I've got a question here. The following data shows the amount of time in hours and the amount of distance walked in kilometers on a bushwalk. Determine the equation of the regression line and display the regression line using a spreadsheet. So we're not going to do the spreadsheet part, but we are finding the equation of the regression line. Remember, regression is the line of best fit. So if these are coordinates here, there's going to be some line that best fits this data. We're going to be finding the equation of that. So on your calculator, turn it on, go up here, mode, number 2 for stat mode, and this time we want a plus bx. And I'm just going to come over here and just write something down. So we want the one that says a plus bx, and this is number 2. And our standard form of a linear equation is y equals mx plus c. So if we've got a plus bx up here, then the b is really the same thing as the m, it's the gradient. So just for demonstration purposes, I'm going to write y equals and then a bx underneath, because b is instead of the m, and then our plus c, well, the c is really the y-intercept, but on your calculator, the c for this particular setup is called the a value. So that's going to help us a little bit later. Okay, back to your calculator. Let's go number 2 for a plus bx. And we should get a table that looks like the table in our question. So the question, it has actually helped us out because it's labeled time in hours as the x and distance in kilometers as the y, but that's not always going to be the case. Sometimes it might be money and time, it could be time and hours worked, it could be a whole variety of things. You need to firstly work out which one is the dependent and which one is the independent variable. So if x and y weren't labeled here, let's go back to the question. Following data shows the amount of time in hours and the amount of distance walked. So if I'm walking for 1 hour, my distance depends on how far I've come. If I've walked 2 hours, my distance would be more. If I've walked 3 hours, my distance would be more again. So in this particular case, the distance is dependent on the time. So time is the independent variable. It's a case-by-case basis, so it depends. With that being said, let's go back to our calculator and insert my values. So first one is 1. You need to press number 1 and then equals every time. So 2 equals, 3 equals, 4 equals. Now let's scroll right and let's go all the way back up to the top and input in your y values. So when x is 1, y is 3.11. The next one, 4.73 equals 6.08 equals 7.54 equals. Okay, now our data is inserted into this table, so we can press on. Next step, we need to get our b and our a values. So let's go second. Let's go stat variable, which is number 1. And this time we've got a whole bunch of different options. This time we want number 5 for regression. So 5, and remember we were concerned with a and b as our terms. So I'm going to press number 1 for a equals, and I'm just going to write that down. So let's put equation a equals 1.705, b equals, let's go back to our calculator, second stat variable 5 for regression, B is number 2, so 2, and then you need to remember to press equals after, so equals, and then this number is going to change, so B is 1.464, 1.464, and now we don't have an equation yet because we need to write it in the form of y equals bx plus a, or what you might usually know, y equals mx plus c. So let's write that. I've still got y equals bx, b is now 1.464, x plus 1.705, and that here is our final equation. So that is using your calculator to find the linear regression of a data set.